All right then, finance friends, let's jump into it and let's talk about our first big calculation, our first big type of TVM, and that is going to be the future value of a lump sum. Okay, so we already established that the time value of money is probably the single most important concept in personal finance. By way of review, you'll recall that compounding is the process of moving from present values to future values. And it can be calculated for either a lump sum or for a series of cash flows. So we can do this compounding. We can move from present to future for either a lump sum or for a series of cash flows, which sorry about that, are also called annuities. Okay, you need to understand and respect this because compounding is a very powerful force. This is what's going to be responsible for helping you to generate the wealth that you want to achieve. Okay, the future value of a lump sum, that's what we're talking about. The future value of a lump sum is how much an amount of money held today will grow to in the future, given a particular interest rate and a specified number of time periods. To solve these future value lump sum problems, you need to know a couple of variables. You need to know the actual amount of your deposit or investment or what you hold today. You need to know the interest rate to be earned, and you need to know the number of years it will be invested. We're going to call this number your present value. We're going to call your interest rate I, and we're going to call your number of years N. Another thing that will help you with this is if you're ever confused, drawing a timeline. Timelines are simple tools that allow you to kind of lay out in visual form, because you want to visualize cash flows. So I always begin by identifying with the variables PV and I and N, and then you can do a timeline. You can say, for example, if you say that you want to know what $2,000 invested today will be worth in 3 years, well, today is always time zero. That's the present value. We would say that's $2,000 in 1, 2, and 3 years. What we're trying to do is move that $2,000 forward. That'll be the future value. And if you know that you're going to make, let's just say 8%, then you put your percent there. And now you've got a graphical way to represent a pretty abstract problem. This will be especially helpful for you when you jump into annuities, okay? So you know how to use a timeline, but the real meat of it, we got to get the formula. So how do you solve the future value of a lump sum? And you solve it with this formula. The future value of a lump sum is equal to the present value multiplied by 1 plus the interest rate raised to the exponent n. And you can see now how all of your different variables are playing in, okay? PV, your present value, that is what you start with. And this critical thing here, 1 plus your interest rate raised to the n, this is basically your compound factor. You'll notice that you're adding 1 to your interest rate, but critically, you're raising it to the exponent of your number of periods, years or months usually. This idea that you're compounding based on an exponent, that's where you grow. So the basic formula, future value equals present value multiplied 1 plus the interest rate raised to the n. Now, that can be kind of cumbersome, so there's also some shortcuts. And specifically, we can use the shortcut from what's called a table. That's the table method. We can determine the future value of a lump sum by multiplying the lump sum amount by what is known as the future value interest factor. The future value interest factor, also abbreviated to FVIF, and you can find this in a table. If you Google search, if you look at the back of the textbook, you can find these tables everywhere. You're going to look specifically for the FVIF, the future value interest factor, and you're going to get that from the table. So the formula would be the future value is equal to the present value multiplied by the future value interest factor. If you notice, let's just do a little example. Let's say that we're talking about an interest rate of 4% and an N of 5. If you notice, the future value interest factor at 4% 5 years, if you look at a table, would be equal to 1.2167. You just pull that right from the table. You notice what this factor is equal to is this part of the equation. So basically, the factor tables give you a shorthand way to solve it. Hypothetically, if you were to do 1.04 raised to the 5 and multiply that out, you would get 1.21665. So if you put the variables for 4% and 5 years into the formula here, you would get 1.21665. You get a shorthand approach of 1.2167, and there it is. And again, it's a shorthand. Like I said, the FVIF value from the table, it corresponds to that part of your formula, and it makes your computations easy. When you look at these, you notice something important. If you look at the tables, you will notice that a longer investing period and or a higher interest rate will lead you to a higher or a greater or an increase in the FVIF. A longer investing period and or a higher interest rate will increase your future value interest factor number. We call the factor number, okay? The idea here is the higher the rate you earn or the more time you have, the more wealth that you're going to accumulate. So again, you take away, you start saving now. You start planning for your retirement ASAP, because time and rate are your best friends in wealth accumulation. Note, however, that the very same forces that will compound the money that you own will work against you with the money that you owe. So the takeaways from this very simple idea: focus on time, net cash flow positive, start saving and planning now, and avoid debt. The principal ideas of personal finance, those basic takeaways, they all stem back to this idea. Let's do, my friends, a little bit of practice just to make sure that we get it. If you want, you can pause the video now, try to work out these 2 questions, then start it back up, and then I'll have your solutions for you, okay? Question number 1. Bob receives $4,000 graduation gift from his uncle. He deposits the entire amount in an account paying 3%. What's it going to be worth in 5 years? We can approach this multiple ways. Let's first lay out our variables. We know that our present value is $4,000. We know that our interest rate is 3%. We know that our N, our number of time periods, is 5. If you were confused by the abstracts, you could also lay it out in a timeline. You could say, okay, you always start today as year 0. You're going to look ahead 5 years. So 1, 2, 3, 4, 5 years from now. This is the present value. It's $4,000. And what you're asking is, what will that $4,000 go to? What will be the future value if you get 3%? So you can visualize the flow of money over time with an attached interest rate to it to help map this out. To solve it, we would say that the future value is equal to the present value times 1 plus I to the n is going to be equal to $4,000 times 1.03 to the 5 equal to $4,000 times 1.1593 is equal to 463710. If Bob invests, sets aside this lump sum of $4,000 for 5 years at 3%, it will grow to 463710. You could also have done this, I'll try to squeeze it in here, with our shortcut. The future value is equal to the present value multiplied by the future value interest factor. And if you were to look it up, you would see from the table that the future value interest factor for 5 periods at 3% is 1.1593, and therefore 463710. Solved. Another question. You just bought a house for $220,000. Congratulations. Where are you living at that price? I don't know. If real estate appreciates at an average of 3% per year, what will your house be worth in 7 years? Same idea. You say, okay, I have it right now. Present value, $220,000. You know that you're going to grow at an interest rate of 3%. In 7 years, what will be your future value? We're going to do that question mark. That's what we're solving. You could theoretically, if you chose, map out a little timeline. You can say right here, our present value of our house is $220,000. 1, 2, 6, 7 years from now, if you push that forward over time at 3%, what will it be worth? And that's how you solve it. We can go a couple ways. Let's do the formula way, then the factor table way. Formula way. The future value is going to be equal to the present value multiplied by 1 plus I to the n equals 220,000 multiplied by 1.03 to the 7 equals 220,000 multiplied by 1.22987, and that will solve out to $270,572.25. You could also, if you wanted to skip all the exponent work, just go to your tables. The future value is equal to the present value multiplied by the future value interest factor for 3%, 7, which will be equal to the present value times 1.2299, and that would solve out to 270,578. You will notice here that we're a little bit off, $6 or $7 off, $7, $8 off, whatever it is. That's okay. If you do the exponent version and you get a longer number, or you do the version and get the shorter number, you're going to have a little bit of an error, a rounding error. That's okay. In the scheme of things, the $6 difference here means nothing. So now you know how to calculate the future value of a lump sum with the formula, with the table. There's also other approaches, but most critically, you should take away from this that time is your best friend. So start saving, start going cash flow positive now, start planning for retirement now, avoid debt, and plug some numbers into these formulas to make predictions on the wealth that you can accumulate over time. Thanks, and I'll see you next video.